Another way for us to determine differences is just to figure out if it's statistically significant difference between the pre-test and the post-test. So in this set of slides, I'm going to show you how you determine if a single score is a statistically significant difference. So here, statistically significant differences just mean that it's not likely due to chance. So this is what the formula looks like from Anastasia and Arbina. It looks complicated, but it's not. So let's go through the different things that you'll need. You'll need a difference score, so you'll need the pre-test and post-test score to get a calculate a difference score. You'll need the reliability of the particular method of assessment that you've used. And oftentimes this is for R1 and R2. So in this case, you'd want to know, if you were comparing, say, an achievement test to an IQ test, you'd need two different reliability coefficients. But in our case, we're comparing pre-test to post-test, so R1 and R2 are going to be the same. And you'll also need the standard deviation of these scores. And then you can calculate it. So using this formula, if you're given the information that you have a standard deviation of 2 and a reliability pre and post test of 0.88, this is how you would calculate the difference score needed. So you have a 2 and a 0.88, so you do the part underneath the square root, 2 minus R1 minus R2. Remembering in this case, R1 and R2 are the same. So 2 minus 0.88 minus 0.88 is 2 minus 1.76, or 0.24. And then remember, because that's under the square root, we've got to square root it, and that now makes it 0.49. Remembering we have to multiply all of that by the standard deviation. We have the standard deviation here, it's 2. So that becomes 0.98. And then remembering again, we have to multiply the standard difference by 0.196, and we get that as 1.92. So what that is saying is that 1.92, we would say really just 2, that you would need 2 points between the pre-test and the post-test scores to say that you've made a statistically significant difference in this person's intervention. So let's say their pre-test score was a 14 and their post-test score was a 17. That's 3 points difference. That's more than 2, so it's more than statistically significant. So here is an opportunity for you to get a chance to practice this on your own. You have enough here to calculate what would be the statistically significant difference needed for both the L and F score and the PSF score. So here is the formula again. So if you had one person who had a 15 points difference on L and F between pre and post test, is that going to be significant, statistically significant? And then PSF. So you may want to pause at this point and try and calculate these on your own. All right, so the next slide is going to be specifically to L and F, and we'll see how you did. So this is the formulation of everything. We just plug in all the numbers into the formula, and you would need 11.9, which is 12 points. So our person got a 15-point difference, which is more than 12 points, so she would have had a statistically significant difference between her pre-test and her post-test scores on this particular instrument. So if we looked at on phoneme segmentation fluency, we calculate everything out. We get 11.04 by just plugging everything into this formula. And the comparison score really is close to enough to 11 that we would say 11 points. She had 10-point difference, so she did not have a statistically significant difference between her pro-test and her post-test scores. One of the things you may be noticing, since we just talked a lot about rate of improvement, is that if she's improving at a certain rate, then we might get a statistically significant difference just if we let her do it another 2 or 3 weeks. If she does another 2 or 3 weeks, she should have 11 points difference or more, and then all of a sudden, then she does. So one of the issues with this particular method is that yes, you can calculate statistically significant differences, but that doesn't tell you all that much in terms of how much more intervention she needs. So this can work for observations as well. So we're going to have to talk about how this works. But, one of the problems with observations is you do not have all the scores you need. You may not have your standard deviations, and you may not have your reliability data. So what you're going to need to do is calculate reliability, inter-rater reliability, and I'm gonna walk you through how you would calculate both standard deviation and inter-rater reliability. So we would calculate the standard deviation here in Excel. So you would give whatever you're going to be using, an observation or some sort of class-based CBM that you created or whatever. And then you would have to give it to multiple people, at least 3 to get a standard deviation. And so we've gotten all these people here. So all we've done so far is just enter this. So in order to calculate the mean, you click on the box, go to function, and we want the average, because remember, mean is just the arithmetic average. And we want the mean between B4 and B9. See, it went ahead and put B10 here, so that means that, and it put a 0, notice the 0 here. That's inappropriate, that's not what we want. We want B4 to B9, and this shows all our numbers, 10, 12, 12, 10, 10, 11, 10, 12, 12, 10, 10, 11. We hit OK, and it automatically calculated it for us. And if we were to change the scores that were in this, it would recalculate the new mean based off of the new scores. So now we have standard deviation. We want to calculate standard deviation. We do the same thing. We go to FX. So I have standard deviation in my normal list, but if you don't, you can always put that in your search term, find it, and go from there. So I hit standard deviation. It's going to be that we are going to be looking for the standard deviation between this number and so that's what we want. We want between 10, 12, 12, 10, 10, 11. So we've got that. We hit OK. And our standard deviation is 0.98. So if this was some sort of observation or whatever, we have the mean and standard deviation. You're going to need to know how to do means and standard deviations for effect size reporting as well. So this is the first step in doing that. So now I want to talk about how you would determine, and for this is really kind of a rough determination of inter-rater or test-retest correlations. So these correlations can stand in for reliability data. Again, there's other ways to calculate reliability, but for the sake of this very basic activity, I'm going to sort of teach you how to work around that using Excel. So over here we have the inter-rater issue. We have 2 raters. Both of them, let's say they observed the amount of time a child was doing something. They did it at the same time. So this person saw it 4 times in the 5 minutes they watched, and this person saw it 3 times in the exact same 5 minutes that they watched. 5 and 4, 4 and 2. And so this is 3 baseline data points, that we would have each person having done. And so now we want to find out what the correlation is between these two. So I'm just going to click on any random cell, hit function, and if correlate is not on here, just do a search for correlation, and you'll get that. And then we're going to decide our arrays. So we want to find out what rater 1, so that's going to be 4, 5, and 4 are those 3 data points. And then rater 2, and we're going to correlate the 3, 4, 2 with the 4, 5, 4 and hit OK, and our correlation is 0.867. So that is our inter-rater reliability data. All right, so that's actually pretty good. So let's look over here and let's say that we wanted a different form of reliability, retest. So we gave the same test twice to multiple kids, Paul, Sally, Jim, and Kelly. We're going to do a very similar thing as we did before, which is click on just any cell, hit function, correlate, and then choose the array of scores we want to correlate time 1. So that's going to be 4432, 4432, 2 time 2. And again, 5534, just double check. And our test-retest correlation is 0.63. So that is how you would use Excel to calculate not just standard deviation and mean, but also how you would calculate 2 forms of reliability. Unfortunately, the formula doesn't say which type of reliability you're supposed to use. So, I tend to say the one you've got is tends to be the one that you go by, or the one that the publisher is discussing. And if you don't have one, then you can see that you can calculate one.